Hi, welcome to the fourth handwritten tutorial on pharmacokinetics. In this tutorial, I'm going to talk about drug metabolism. Drug metabolism often takes place in the liver, but metabolism can take place elsewhere, such as in the lungs or the gut. The fact that most drugs get metabolized by the liver is very important for pharmacokinetics, because drugs given orally may be metabolized by the liver before they reach the systemic circulation. This phenomenon is known as first-pass metabolism. Sometimes first-pass metabolism is so dramatic that it necessitates giving a drug intravenously, as giving it orally would lead to significantly less active drug in the systemic circulation. Morphine is an example of this, which is why it is so often given intravenously rather than orally. However, in this tutorial, I'm going to talk more about the biochemistry of drug metabolism, in particular, the actions of cytochrome P450 enzymes, which are often abbreviated CYP. These cytochrome P450 enzymes are abundant in the liver, and different types metabolize different drugs. For example, CYP1A2 metabolizes caffeine, whereas CYP2E1 metabolizes alcohol. Cytochrome P450 enzymes metabolize drugs through a variety of processes. These include oxidation, hydrolysis, and hydroxylation. So let's have a look at how this works, and I'll try and keep the organic chemistry to a minimum. Here is a drug, and this drug has a hydrogen attached to it. This hydrogen is going to be the target of our cytochrome P450 enzyme. Through the process of hydroxylation, the cytochrome P450 enzyme has turned the hydrogen into a hydroxyl group. But metabolism doesn't stop there. The presence of this new hydroxyl group creates a target for much larger molecules to be attached. There are many enzymes which can act upon this newly formed group. Here we will look at a common one, UDP glucuronyl transferase. Through the action of UDP glucuronyl transferase, a large glucuronic acid group is attached to the drug. This is the same process that happens in bilirubin metabolism. See the bilirubin metabolism handwritten tutorial for more information. Anyhow, the glucuronic acid group has many polar groups attached to it, namely 3 hydroxyl groups and a carboxylic acid group. This makes the molecule extremely water-soluble or hydrophilic. Thus the drug can be easily filtered and excreted by the kidneys. We call this first part of the process phase 1 metabolism. The second part of the process we call phase 2 metabolism. Let's have a look at an example now. This molecule here is aspirin, or more correctly, acetyl salicylic acid. The phase 1 metabolism of aspirin involves a cytochrome P450 hydrolyzing the aspirin molecule, and the resultant product is salicylic acid. This is particularly interesting as salicylic acid is the active drug. In other words, aspirin needs to be metabolized before it has any effect. Because of this, we call aspirin a prodrug. Salicylic acid can then be acted upon by UDP glucuronyl transferase to attach the glucuronic acid group in place of the hydroxyl group. Now the product can easily be excreted by the kidneys. And that's an overview of the metabolism of drugs. In the next pharmacokinetics tutorial, We'll talk about the excretion of drugs and drug metabolites.
Yeah.